In today's video, we're going to talk about working on the chain plates. The chain plates are the piece of hardware that connects the standing rigging of the boat, which is the wires that hold the mast up, to the actual hull. So it's just like usually a piece of metal that connects from the turnbuckle on the rigging to the hull. And the original Cape Dory chain plates are these bronze pad eyes, and they just mount out here on top of the deck. And it's a pretty good design. The only kind of flaw in it, which it ends up being kind of a big deal, almost fell in the bilge there, is where they attach underneath. So there's two long stainless steel 1/2-inch bolts, and they attach into the top of the deck, and they go through just some regular mild steel plate that's encapsulated. That means it's carried inside the fiberglass on the deck, and it also kind of runs in along the hull. And the problem comes in with there wasn't like a special metal that could resist corrosion. It's just regular steel, and you can see it's just all basically kind of dissolved, and you can just chip away the old bits with your fingers. You weren't able to see this until I cut away the part of the headliner. So this fiberglass piece used to come this way and go down, covering up the old backing plate, so you couldn't tell that until I cut that away. And honestly, it probably would have been okay. I sailed the entire East Coast, and I sailed in the 40 knots of wind at one point, and the boat that held up this long, it probably would have, just the thickness of the hull probably would have held it together. But it really is a little bit sketchy. It doesn't feel ideal. And so I thought it would be a good idea to replace it. Originally, I was toying with the idea of just kind of reinforcing this inside of the hull where the chain plate bolts go through, like maybe adding some extra fiberglass or carbon fiber, or maybe some metal backing plates. Ultimately, I ended up going with just the tried and true metal straps bolted to the outside of the hull. It's just seemed like it'd be really easy to implement, and I was really confident it would create a strong connection from the rigging to the deck.
I really hate opening these cardboard tubes. They're stapled so good. Chop saw makes pretty quick work of that. I just got these two, massive pieces of bronze. Yeah, so 48 inches long, and I'm gonna cut them into thirds. They got two pieces here, and these will become the shroud chain plates. 0.375 inches by 1.5 inches, and it's aluminum bronze, I believe. I think a silicon bronze is more ideal because it's easier to bend and retain more strength. But since these are just the shroud chain plates, I don't need to bend them. Maybe a little bit of a bend on the lowers, but we'll see. I can also heat it up. I got the oxyacetylene here. So I'm just gonna cut it up on the chop saw now. This was close to $300 worth of bronze right here. So hope I don't mess it up. This glittery chips, so fun. So here they are. You got 6 of them. Pretty close to the same length. You can see the old bronze chain plates. I made these a little bit thicker. Doesn't hurt. And it might make it harder to drill through them. Here's the first hole. The bronze drill is really nice. I think a step drill bit was the way to go. And the pin fits in there just perfectly. So I think I'm gonna kind of round over these edges just a little bit. Might not do a full round, but just to kind of make them not so sharp. So one issue I ran into was, even though I ordered 3/8 inch, I guess it comes milled oversized, so it's almost closer to 1/2 inch. And the cap shroud toggles fit just barely, but the lowers are a little snug. I actually had to widen it up to get the toggles to fit over the chain plates. So I think that's not really ideal. They're supposed to be able to kind of like move freely, I believe. So
I might end up either maybe ordering larger toggles or grinding this area a little bit smaller. Maybe it's time to get one of those big disc sanders. That'd be kind of nice to have. Before I drill the holes in the actual bronze chain plates, I want to put them in the hole first and make sure they don't hit anything on the backside that's going to be problematic. So I'm making this template where I think that would be a good place for the holes to go. And I'll just use that to drill them in the hole, and if they work out fine, then I can just transfer them easily to my chain plates. This is where they'll set. And you can see they're just moving them 2 inches outboard, really, so shouldn't be a big deal. I drilled my first hole, so I'm gonna go inside and see where that ended up. So here's that first hole right here, and it came out in just the right spot. It would have been kind of annoying if it came up in this like metal bar. It looks like the one above it will end up a little higher than I probably would have liked. Maybe I'll bring that down, but the bottom one looks like that'll end up just right here. So we look like we're golden there, and then on this side we should be fine too. And then on the other side, I don't think there's really anything going on. Over here, I will need to probably remove the rest of those slats and maybe cut away some of that fiberglass backer. And after about an hour of drilling, we have all these chain plates done. That would have taken about 3 times as long if it was stainless steel though. In this area, I'm cutting away the inner liner. I've already cut away some of the wooden slats because we need to get to the outer hull so we can put our chain plates in there. I thought it would be a good idea to add some additional reinforcement on the inside of the hull since the chain plates weren't originally designed to attach there. So my friend David came on with his vacuum bag, and he had this leftover carbon fiber woven, and this will let us get a really compact, really strong set of reinforcement patches on the inside of the hull. So here we're kind of wetting out the carbon fiber cloth with epoxy resin. And then once we get that good and saturated, we'll kind of press that on the inside of the hull. You don't need quite as much resin with vacuum bagging because the vacuum, there it is right there, will suck all the air out and make the layers really compacted together and gets you really quality layup. So the vacuum bag didn't work out on this side, so we're just switching to hand layup, trying to get these voids out. All right, so we've got 2 layers, a layer of the fine weave and then the thick stuff in the middle, and then another layer of the thinner stuff.
And then another layer.
And then, 2 layers, okay. Yeah. And then peel ply. So this will go on the kind of the aft chain plate. All right, chime number 2.
Make sure we got it fit.
The size looks just right, yeah.
Beauty. Okay, now we gotta
Pull this.
all that. Yep, and we go ahead and do that. And we got a sponge. Probably sitting in one.
Okay.
And I'll do this. Okay, I need to get some beetle around that.
Beetle.
You hear that?
Yeah.
Sounds like it's like right here. We're making progress. And you know, if you see dry spots, you can kind of massage the resin around.
Ah, okay. Put that once the leaks out. I'm trying to get rid of these leaks. I don't know if I'm a fan of vacuum bagging. So the vacuum bagging is finished. We did this one. This one was the last one we vacuum bagged. It came out pretty good. And then we have this one over here, which that one worked out all right. This one, we started vacuum bagging, but then the vacuum wasn't working at all, so we ended up just kind of like hand laying that one up. And then this one over here, we vacuum bagged. Worked pretty good, except it wasn't quite able to suck the vacuum in over there. But it feels pretty well compacted there. And then this one, I was pretty sure it wasn't gonna get a vacuum because of all these holes around here. So I just did a hand layup on this. And that one looks pretty good too. I never tried vacuum bagging. It always seemed kind of intimidating because of all the different things you had to have, but it wasn't too bad. It was kind of a hassle, I will admit, but it wasn't as bad as I thought it would be. And I think we had a difficult situation working vertically, you know. That made it harder to set up, and all these really irregular surfaces, they were kind of leaky. I think it would be easier to do it if you had a more controlled like environment. I think this is hard enough to pull the peel ply off. Yeah. Wow. That is a beast. So, actually, it seems pretty solid. It'll be plenty strong enough. We just wanted to kind of spread the load out a little bit more on the hull. Is the sponge going to be a part of my boat now? This one, I think, came out the best. So now these are kind of floppy, so I'm just gonna drill these holes and put more screws on the end. Today I'm drilling the holes for the chain plates to the final size. This is what they're gonna look like. I ordered some 1/2" 3/16 stainless 3-inch long bolts to go in there, and that should be more than strong enough. These chain plates are going to be beastmode911 strong. It's way stronger than the rigging. Eventually I will probably change to synthetic rigging when I re-rig, but that's not going to be for a few more years probably. So chain plates can be made out of a lot of different materials. Most boats you'll see have just stainless steel ones. And that's originally what I was going to go with, but after doing a little more research, I really decided that bronze is a far superior metal for chain plates, especially if you're going to do it yourself or are concerned about longevity. The problem you get with stainless steel is, especially in the areas where they kind of are connected to the hull or they go through a deck, you tend to get these kind of pits and corrosion. And actually, back when I bought the Ranger 23 that I sailed to Hawaii, that's one of the things I always look at is the chain plates on the rigging. And when I bought that boat, it was actually something I used to negotiate the price way down. The chain plate was cracked almost all the way through. It was only held on by like a couple millimeters of metal. It was insane. So I ended up pulling all the chain plates to check them all, and I replaced that one. The rest of them looked okay. There can be corrosion even hidden like underneath the metal that you can't see. So with stainless chain plates, they really do have a lifespan, then they need to be replaced. And that's not the case with bronze. It's almost the same exact strength as the stainless steel, even though it's a softer metal. So you can really just kind of size it about the same. The real advantage is you don't get that crevice corrosion. It'll turn green and it won't look, shiny like the stainless steel, but the strength just remains. Another thing that makes it really nice for if you're going to be building them yourself is it just drills like butter. It's so easy to machine. I've built stainless steel chain plates before, and it would take just probably 3 to 5 times as much effort to drill through the stainless steel, and you're always having to sharpen the drill bits and worry about work hardening the metal and stuff like that. The bronze is it's worth the extra cost. So bronze ends up costing about 3 times as much. So with this project, I think it was about $250 for all the bronze, plus another $50 of shipping. And I bought it from Online Metals. If you're trying to look for some sources of bronze, seems to be an okay way to go. If you're near one of the warehouses, you can pick it up locally, so you don't have to do the shipping. But I think the extra cost, just for not having to buy fancy cobalt drill bits and stuff, you could probably come out ahead just going with bronze. And then you have these chain plates that are going to last forever. More exotic materials you can use, carbon fiber or fiberglass. A lot of times you kind of gotta do fancy things with the layup, I think, to get them to work, or they're like usually integrated in the hull. Some people also have used titanium, and that's even harder to machine than stainless steel, so you don't get really any advantages there. The only advantage is really it's similar to bronze, and it's kind of inert. It's not gonna get that kind of corrosion, and it's more lightweight. But I mean, this for the amount of weight that chain plates add to my boat, I don't think you're really saving all that much going with titanium on a 10,000 pound boat. Well, that's where I'm at right now. I'll see you guys next time.